Okay, everyone, I think we can start. So today we will be discussing about an end-to-end project. So I will just try to give you an overview about whenever we talk about machine learning or data science. So what happens in an end-to-end project? So obviously you will see here that there will be like it will not be like only one algorithm which will be making use of. I already told you. In real time, we will find out we generally make use of at least 5 to 6 algorithms at a time. We never depend only on one algorithm, everyone. Right. So the model which we have seen in the last session, like let's say suppose linear regression model, right? So there, if you remember, it was only linear regression is that's what the only one algorithm which we have used. But that is not the case, everyone. As I told you, we never depend only on one algorithm. We actually go with more than one algorithm whenever we want to work on some end-to-end project. So something like that only I will be showing it to you, everyone. Right. So here, maybe I think, okay. So I will show you one problem statement. We will try to solve that particular problem statement. Okay. And I will explain you what is that problem statement all about and what type of a data we have. Obviously, this is not the task of only one person. There will be like a team of people who will be involved, like who is actually involved in creating this kind of a project. So whatever you people are able to see, all these are the modules present in my project or the application we can say. But as I told you, we will not be depending on only one algorithm. So you can see that everyone I have used like 1, 2, 3 algorithms I have. So why is it so? How we can actually make use of more than one algorithm? Why to use of make use of more than one algorithm? We will see that. We will talk about that. So before doing all these things, everyone, I need to just make. I just want you people to understand the problem statement itself. As I told you, this is not the problem statement where we have used only one algorithm. Okay. So let me show you. See everyone, this is a folder actually where I have project. This is the folder. In that folder, I have all these folders. Okay. Each subfolder is nothing but one module in my project. It is one module. As I told you that we will be going and discussing about an end-to-end project, right? So I want you to give a basic idea here. So whenever you say machine learning data science, what actually happens? Why? Why there is a need of more than one algorithm? Or why generally one need to know about as many number of algorithms as possible? See, till now, like even though we see linear regression and logistic regression, but I told you that it's not like that there is only linear regression or logistic regression. There are other algorithms also available, right? So why? Why do we actually learn about all those algorithms? See, if I talk about let's say a prediction type of problem, if I talk about a prediction type of problem, now to solve prediction type of problem, there are different algorithms. Linear regression is one basic. Linear regression is one basic algorithm which we generally make use of. But there is not only linear regression. So there is something called as decision tree is present. There is something called as random forest. There is something called as XGBoost algorithm, which is again one of the best algorithms, right? Extreme gradient boost. This is called as queen of machine learning algorithms. Then there is support vector machine. Then there is naive-Bayes algorithm, and so on. So why? Why we should know about as many number of algorithms as possible? Because see everyone, it depends on the data set which you have. It depends on the situation. It depends on the problem statement which you are going to solve, and it also depends on the domain, right? So the application which we have done in the last session, which we have discussed, like prediction of the chance of the admission to foreign university for some student or some person. So there we have used only one algorithm, and that was only linear regression. But that is not the thing which will happen in real time. Let me show you a problem statement. There is a documentation which I will explain you, where you will see that the problem statement itself is explained there. This is the problem statement everyone which we are going to solve. And in implementation you will see we have used more than one algorithm. As I told you, right? Like I will be showing you some end-to-end project where you will see that we have used more than one algorithm. So how is it possible to make use of the algorithm? For this, if you remember, that after discussing about linear regression, we also discussed about logistic regression. Now, in logistic regression, if you people remember, we have seen something called as ROC AUC score. Now, I don't know how many people remember that. Okay, ROC AUC. So, if you remember, we have seen something called as confusion matrix in case of logistic regression. Confusion matrix, I already explained it to you. Even we have seen the implementation also in case of logistic regression. So we discussed confusion matrix, and from confusion matrix we discussed about some matrix that is called as accuracy we have discussed. Then there is something called as precision, right? Then there is something called as recall. All these are nothing but metrics which will tell you how your model has performed, right? Then there is something called as F1 score, and finally we have discussed like true positive rate, false positive rate, and based on true positive rate and false positive rate, we have discussed something called as ROC EUC, receiver operator characteristics area under the curve. This is what we discussed earlier. Now, this is the concept which we will be making. This is the concept actually which we will be making use of to find out which is the best algorithm for a particular data set, like which is the best model. And generally, we first of all do clustering, and then on each cluster we apply the algorithm accordingly. Like if you want to solve a prediction problem or maybe a classification problem, depending on that we apply the algorithm. But ROC EUC score, see everyone, there is something called as ROC EUC score. This is what we generally make use of to find out the best model. Okay. So if you like, if I want to give you a basic idea here, everyone, let me tell you what I am trying to say. See, everyone, this is the problem statement. To build a classification methodology to predict the type of thyroid based on the given training data. Okay. Now, even I will be showing you input data set also. Let me tell you everyone, here the input data set is not only one file. There are near about 30 files which we have as input files. Okay. So it's not only one file because the data is coming in batches. Right? Data source can be different in different situations in real time. Everyone, we have like more than 30 files, and in the file actually, if you check, there is an output column or target column, and that column is nothing but class. So that class column is nothing but the type of a thyroid. And now the type of thyroid are four. The first type of thyroid is primary hypothyroid. See everyone, this is nothing but one of the types of thyroid. Okay, primary hypothyroid. Then there is another type, that is secondary hypothyroid. Okay. Then there is something called as compensated hypothyroid. All these are the classes of thyroids, and then the person can be negative. So these are the four possibilities, these are the four categories in the output column available. So it's not like a binary class classification problem. What we want to do is, given some symptoms, our model should be able to classify a patient as affected by primary hypothyroid, secondary hypothyroid, compensated hypothyroid, or a patient as a negative. This is what our target is. And everyone, in this documentation, I have given all the details about the architecture, the details about the data, training data, testing data, and finally, obviously, as usual, I have given the details about the deployment part also. So how it, so see, prediction, data description, validation, and I am using some database also, that is nothing but SQL Lite3, which is a lightweight database. Lightweight database means it will store the data only for temporary purpose. So everything is given in the PDF. I will go and I will try to talk about this particular architecture also. But before that, everyone, let me tell you, like, just let me give you an idea about what happens in case of real-time project. How we go, how we do the classification or prediction, and before doing the classification and prediction, what we actually do. Okay, so that's what I want to explain you first, everyone, and then we will go and then we will talk about the implementation. So I will go reverse way because obviously 2 hours is not sufficient to explain you everything about the project. So what I will be doing is, first of all, I will be showing you some basic things which we generally follow in real-time projects. See everyone, maybe generally whenever we try to solve some classification prediction problem, you might have seen that the data which is coming only from one file. But in real time, it is not going to happen like that. In real time, you will be getting the data from some live source, maybe from maybe data might be coming via streaming, data might be coming via some database, maybe relational database, non-relational database, like MySQL, it can be maybe Oracle, maybe a MongoDB, maybe Cassandra. There are a lot of things. Kafka, some messaging techniques like Kafka, data might be coming through Hadoop, and so on. Right. Once we have the data, everyone, what we generally do is see. Let's say this is my data. Obviously, in real time, we will be getting huge data. The size of the data set is going to be huge. So, everyone, this is just an overview. Please try to understand. I will just try to tell you the process which we follow. I am just trying to give you an overview of the process which you generally follow in real time to get either a prediction model or a classification model. So everyone see each of these markers, whatever the you are able to see all these markers, you can imagine them as a record or one row. All these are nothing but number of records in your data element. Okay, all these are nothing but number of records. So thousands of records we have it. Now see everyone, as this is our data, so we don't know which algorithm to apply. But let's suppose I want to solve one prediction type of problem. I want to solve a prediction type of problem. So now for prediction, there are different algorithms, right? So let's suppose maybe I want to solve a problem where I want to predict salary of an employee, or how many runs a player is going to score in the next match, or what is going to be the profit in the next month, or maybe next 2 months, and so on. Okay, so I want to do prediction, or maybe even I want to do classification, whatever it may be. You can solve any one of those. Okay, so everyone, what we do is in real time we never directly go and apply the algorithm. See, whenever I say prediction, now for prediction we have different algorithms. Everyone, I told you already, right? One can apply linear regression for predicting. Maybe one can go with decision tree. Decision tree also can be used for prediction. Then there is a very good algorithm that is nothing but random forest. This algorithm also one can make use of for doing prediction, right? And then there is something called as XG boost, extreme gradient boost, is also one of the best algorithms for prediction as well as classification. And even KN and k-nearest neighbor can also be used for prediction. Even Neo-Bayes algorithm also can be used for prediction, right? And other algorithms can also be used. So see everyone, we never directly go and apply this. I am not talking about training and testing split everyone. Okay, obviously that we do, but we never apply the algorithm directly. What we do is we apply unsupervised learning technique first. I already introduced you to different types of approaches of machine learning, right? Supervised, unsupervised, semi-supervised, and reinforcement learning. So unsupervised learning is what we generally apply. This is one of the best approaches which is again applied or used across the industry. So what we do is we apply unsupervised learning approach, and obviously then it is going to give us what? It is going to divide our data into different clusters. You know everyone, right? Unsupervised learning, whenever I say, there are different algorithms in case of unsupervised learning. There are famous algorithms everyone, right? And like I told you already, if you are not aware about any of the algorithms everyone, so K-means is one of the best algorithms, but again there is not only K-means algorithm, there are other algorithms also. But still, if you really want to understand it in easy way, right? Here also I have mentioned it. I already told you, if I go with that particular thing, maybe I will not be able to explain the complete project. So those who are not aware about K-means, maybe you can go and you can check this out. See, here I have explained in a very simple way. If you want, you can always go. Otherwise, if you are aware about it, that is good. No problem at all. But those who are not aware about, so you can go and you can just check the basic idea behind K-means algorithm. Here you go. This is a very simple example. I have just taken the data set and I explained you what is clustering and how we actually do the clustering with the help of K-means algorithm. But remember everyone, there is not only K-means. There is not only K-means algorithm, there are other algorithms also. So everyone, you can always refer this, right? And even there is one more algorithm, that is DB-scan. Generally people are not aware about it. This is also really very good algorithm if you want to go and if you want to do clustering. Okay, so this particular video maybe you can check. if you are interested. Otherwise, you can always ignore it depends. Okay, but as I am talking about this particular thing, that's why I am showing my explanation. Otherwise, you go, you Google, you will get lot of resources. Okay, so either you go with the DB scan or you go with the K-means. Any one of this will do everyone. No problem at all. Any one of this will do. So I will just try to show you what we do with the help of those algorithms. So generally, most algorithms you will see that people will go with K-means. But again, it's not only K-means. There is also one algorithm that is called as DB scan. For both of these, if you want explanation, I share the link. If you want, you can always go, and even you will be able to see that implementation also I have shown in other videos. Okay, this is what it means. This is nothing but clustering algorithms. So what it means? What has happened? It means either K-means or DB scan is going to give you what? K-means or DB scan is going to give clusters. So the data, what I can say, the records, right? The records, the rows, which are having similar properties, which are similar in nature, right? Maybe if there is some similarity between them, they will be in one cluster. This is called as one cluster or one group. And the data points which are different than that, they will be in other group. So everyone, I am just trying to make the different colors because I want to show you that these data points, they have something similar, some similarity in between them, and that's why they are in one group. So like this, let's suppose I got maybe 3 clusters or maybe 4 clusters or 10 clusters or 100 clusters depending on the data. Just for understanding purpose, let's say I will say that this particular data is having 3 clusters or 3 groups. So yes, everyone, K-means let's say has given us 3 groups. Okay, K-means has given us 3 groups. Now this is cluster 0, this is cluster 1, this is cluster 2, 0, 1, 2. And now as what we wanted to do, everyone, we wanted to solve a prediction problem, let's say, or classification problem. Then for prediction, let's say I have used linear regression. So you need to use linear regression on all the clusters. But as I told you, we never depend only on one algorithm, everyone, right? So let's suppose I applied random forest also. So you need to apply random forest on other clusters also. Okay, cluster is nothing but what, everyone? Group. I hope everyone is aware about that. And let's suppose I applied some another algorithm. Let's say XG boost also I have applied XG boost. Right, so you need to apply that particular algorithm, extreme gradient boost algorithm, which is again one of the best algorithms in machine learning and data science. So let's suppose I apply that particular algorithm on all the clusters. Like this, you can apply 3 to 4 more algorithms. Okay, let's suppose I applied 3. And now the thing is, obviously, every one of these, they are going to give you model. They are going to give you model. So how to choose the best model out of this linear regression, random forest, and XGBoost for first cluster? This is where ROC AUC score is going to come into picture. The thing which I have discussed in the last session, that is ROC AUC score, receiver operator characteristics area under the curve. Okay, and you have a direct method to calculate this. In the implementation, I will show it to you. Okay, because I will directly show you the implementation. Going and typing everything is not going to be possible. Okay, so see what's going to happen is, let's suppose random forest has given me the best model for 0th cluster. So this is going to be my first model. Okay, and then let's suppose here linear regression has given us the best model. So this is going to be my second model. And let's suppose here also random forest has given me the best model. So this is going to be the third model here. So 1, 2, and 3 models we got. So these are going to be your final models here. And now when client is going to send testing data, or the data for testing in real time, if client is going to send, now same process is going to be applied for that data also. Let's say this was training data. So for training, now we have the trained model, and now there is the testing data. So that testing data will also be divided into different clusters. But do you really need to go and train the model now? No. So the data set which belongs to cluster 0, it will go to which model, everyone? It will go to random forest 0 model, because this is the best model for 0th cluster. And this data will go to where? It will go to linear regression 1, and this will again go to random forest 2, and then you will get the results here. This is what we generally do, or the approach which we apply in real time. This is how we apply it. Okay, that's why I told you that we never depend only on one algorithm. Whenever we want to go and we want to create the model, we always go and we always try to make use of more than one algorithm. Here I have shown only 3 algorithms here. But I said that many times you will see that if you apply 5 to 6 algorithms at a time, and then from that, whatever the best algorithm is, or whatever the model which is the best, that model actually we go and we try to finalize. And again, obviously, there are some techniques to go and to improve the accuracy of the model. That's also possible. Something called as hyperparameter tuning is possible. So yes, one can always go and one can always make use of hyperparameter tuning to improve the accuracy of the model. Obviously, that's possible. If let's suppose client is not satisfied with the accuracy, then one can go and one can tune the parameters of the model, and you can come up with the higher accuracy model. And to tune the parameters of the model, obviously one should have a better understanding of the algorithm. Okay? That is also one main reason why you should be knowing about the algorithms and the basic statistics behind that and the working of the algorithm. Implementation, as I told you everyone, if you go and if you try to see, just if you go and if you try to Google, you will be able to see the code. Like if you just Google, let's say, about linear regression implementation or XGBoost implementation, definitely you will be able to see implementation with some examples. But many times you will see that even in live projects also, like in many companies, those people who are, so you will see that they generally get the models which are already developed. They just need to go and tune the models or tune the parameters of that particular model so that it is going to give us the best accuracy or higher accuracy. Right? Accuracy, I mean to say, it should give us the good results. Obviously, if the model is not giving the good results, then what will you use, right? So I hope everyone you got an idea about or an overview about how we apply, what is the approach, how we get the model like this, right? And how the best model is decided. Something called as ROC score, we go and we calculate it, right? So hope everyone, I hope you got this idea, right? If anyone is having any difficulty, please let me know. If anyone is having any difficulty, please let me know. Otherwise, I will keep it. And I will just try to talk about if someone is not able to understand whatever is going on here, please let me know. Anyway, so hope, I think, let me check in the chat box. You can always let me know in the chat box. Fine. I am not able to see anything in the chat box, so I will assume that you people are able to understand me. Now, I will show you the execution everyone. What is the project all about? Whatever I am talking about, see, I will show you. See everyone, as I told you that this is an end-to-end project, so obviously one cannot go and one cannot develop an end-to-end application of the project with the help of Jupyter. Jupyter is just a notebook. Whenever you want to go and whenever you want to create an end-to-end application, you need some IDE, right? Integrated Development Environment. So that's what we have done here. I have used one IDE, Integrated Development Environment. Obviously, I use PyCharm. The last time also I showed you PyCharm, right? But it was a simple application. This is the end-to-end project. So here also I am using PyCharm method. So you can see all these are the modules in my project. This is nothing more the documentation of the project, okay? To build a classification methodology to predict the type of thyroid based on the given training data. So see everyone, I will show you training data. What is the training data? See, we have training data. As I told you, training data is not only one file. Training data is all these files. All these 28 files are the training data. You can check it again. All these 28 files. Till now, maybe most of you what you have done is like only one file you have, and then that one file is your data set. But in real time, what happens is data might be coming into batches like this. So batches, I mean to say, client is putting the files at some location on the server, and continuously client is putting those files on the server, and then like as a developers, we are just going and we are just trying to fetch all those files from that particular location, and then maybe train and test from that particular data. So everyone, you can see that this is nothing but input data which we have, training data which we have, from which we want to train the model. Let's suppose if I open any one of these files, let's say if I open this particular file, you can see the data which we have been given. Okay, you can see everyone. Okay, now see everyone. If you look at this, you can see the data, whatever we have been given, right? As I told you, what we want to do is we want to create a classification methodology. That means if we have all these things, all these attributes of the patient, symptoms of the patient, or the tests done by the patients, that if we have all these things, our model should be able to classify that patient into one of the classes. Right? See, All these are the features: age, sex of the person, whether the person is on thyroxine or not, query on thyroxine or not, on antithyroid medication, whether the person is sick or not, pregnant or not, thyroid surgery, and maybe like if you are knowing about it, if you have ever tried to look at the reports of the thyroid patient, you might have seen there is one important parameter which is always taken into consideration whenever we talk about a thyroid patient, and that is nothing but TSH level. TSH level. So you might be knowing that TSH stands for thyroid stimulating hormone. Right? This is one project related to healthcare domain area. Okay, so thyroid stimulating hormone. This is something very important, which is considered as a one of the parameters to decide whether the patient is affected by thyroid or not. So maybe in many thyroid patients reports, if you have come across by chance, you might have seen something called as TSH. So that TSH level is also considered here. You will see there is something called as TSH measured, then this TSH, and then T3 measured, and so on. All these are the different test results which we have. Okay, so humor or not, and so on. Right? You can check it. All these are the input features everyone, and finally you can see that there is a feature called as referral source. That is from where that particular patient has been referred, right? SVI, SVHD, other, and so on. And finally, everyone, this is our output column. This is our output column. Class is our output column, right? So as I told you, as output is given, as target is given, or the label is given, that means the data is labeled. As the data is labeled, that means this particular problem can be solved with the help of supervised learning approach. That means there is a supervisor, right? So yes, this problem can be solved with the help of supervised learning approach. And all the remaining columns everyone are going to be our input columns, right? So all these columns are going to be input columns or input features everyone. I hope you people are getting the point. So input is known, output is also known, and you can see that like this we have 28 files. So you can see a patient can be negative, a patient can be affected by compensated hypothyroid, patient can be affected by primary hypothyroid, and maybe somewhere you will be able to see patient affected by secondary hypothyroid also. That means actually there are 4 classes. This is just one file which I have opened in front of you, but there are 4 classes. So what we need to do is, from this particular data, we need to create a model. So to that model, if we pass all these input columns, it should be able to tell us the class to which the patient actually belongs. So everyone see, as I told you, in the folder called as training batch files, we have been given all these training files. So obviously in these training files, there is a input as well as output. So we are aware about the output. But what client is saying that, and again, even client has given us some files also to validate the data which is coming from the source. Like client is saying that the file name should start with hypothyroid. Let's say this file name is not starting with hypothyroid. Then there should be underscore, and then there should be digits, and then underscore, and then digits. So this format is also decided. I will take general steps also everyone. What happens whenever some project actually comes, what happens, how everything starts, what client will give us, all those things also I will be discussing later. So general steps I am talking about. Whenever we work on some projects, at the start what actually happens, those things also I will be talking about. But everyone, I hope you got the point. All these files, whatever you people are able to see, all these files are nothing but what? Input files. So from this, it is expected that we should train the model. And once the model is trained, then client is saying that, okay, I will be sending the testing files in this location, prediction underscore batch underscore files. So in this location, if I go, you will be able to see some files. So these are the files for which client want to do the classification, or these are the files for which client has given us some testing data for which client want answers. So here you can see all the columns, all the features are same, except obviously there is no output column, because output column we want to tell it. Depending on all these features, right? We want to tell what is the class to which that particular patient belongs. So this answer we want to tell the client. Obviously, this is testing data. This is the testing data, right? So we want to find out the answer for it. That's what client is expecting. This is our simple problem here. That is nothing but to build a classification methodology to predict the type of thyroid based on the given training data. Okay. So this is our basic problem. All these files, whatever you people are able to see, everyone, all these files are nothing but what? Testing data. This is the file for which we want to tell the client whether the patient is affected by primary hypothyroid, secondary hypothyroid, or patient is affected by compensate hypothyroid, or the patient is negative. This is what we want to tell the client. Hope you people are getting my point. But still, those who are listening me, if you have any doubt, you can always let me know. Okay. So I hope as there is nothing in the chat box, so I will expect that everybody is getting. As usual. Okay. I don't know how many people are listening me. Anyway, so see everyone, now I will show you the execution. All these are nothing but modules. Okay. I will open this particular folder. Go inside this. Simply right click. PyCharm everyone is installed in my case. PyCharm is just IDE. Anyone can install it. You can Google and just download the executable file and you will be able to install it. So here just go here. Click on this. Fine. Now it's going to open everything, all these files and folders into PyCharm IDE. As I told you, I will be going reverse way. First of all, I will show you the execution itself, the project itself, and then we will go and try to see the general steps. So that's why I am going reverse way. Meanwhile, if you have any doubt, you can always raise your questions in the chat box. So what it is doing is it is simply loading a particular project. You will be able to see all the modules in the PyCharm itself. Okay. There are some extra files also, like we have used .html file for front end. But I will tell you one more way to run the project. There are different ways to save the input to the project. See everyone, what we will be doing is we will be sending that prediction batch files data as an input to the model. See, because here the model is already trained. If I go and if I try to show the training also now, it will take a lot of time. See everyone, what I will be doing is from this data model is already trained. Now what we will be doing is we will be passing this data as an input to the trained model, and our project should give us the output. Where you will be able to see the output everyone? The output will be here, prediction underscore output underscore file. So you will be able to see a file like this. A file like this you will be able to see prediction. If I hover my mouse here, you will see that it was created on 15th of December. Now if I run the project, you will be able to see that this file is going to be created once again and today's date with current time. We will be able to see that again. Okay. So our output will be here again. Final output will be able to see here as the file, and this file we are going to send it to the client. That's what we are going to do. So how we do that? See now, I will go to the PyCharm here. The first thing, I think in the last session also I told you, the first thing you need to take care is always go and create the environment. You always need to create an environment here. So in my case it's created. I told you already how to create it. So if you go and if you click on the terminal, you will be able to see the name of the environment. Maybe in my case it is base. Let's see, or maybe some other environment. 3D1 I think I have already created. I simply see thyroid detection 7. This is the name of the environment which I have done in my case. How to create the environment in case of PyCharm or in case of Visual Studio Code? Exactly same thing. See, just go to the settings. Go to settings, you will be able to see some window pop up like this, and here go to this project interpreter, and if you want to create a new environment, click on the setting button and you will see this one. Click on this. You will be able to see this add and show. So as we want to create a new environment, I should add the new environment. What you can do is simply go here, click on this add. Now you can see we have option called as virtual environment or Conda environment. In my case, I already have Anaconda's Python running, so I can go with Conda environment. One can go with this one. So go with this, give some name here, and then say OK. Okay. In my case, as this name is already used, that's why I'm not able to use OK as active button. You can go and you can change this particular folder. See, let's suppose I do something like this. This OK button is active. Because it is going to create a folder with this name, And in my case, the folder with this TD name is already created, and that's why this is inactive. Environment location directly is not empty. Obviously, earlier I actually created that. That is the way. So see again, this is how you can create the environment. If I click on OK, it will automatically create the environment. You don't have to do anything. So environment is like what? Environment is like a clean slate. Means there is nothing. No package, nothing is installed. Whatever is the basic thing which we need, that is the only thing which is installed again. Otherwise, you need to go and you need to install things as per the need. Right? Like whatever the libraries and the packages which we need, you can go and you can install them one by one as per your need. Okay, so you can see even this is like okay, this is the situation. Actually, this is what we have. This is what we have, and this is the environment I created. Right now, I will go and I will try to show you the running version of this. I will go to run. Click on this, run, and let me run it. Yes. Now here you can check. I will go and I will go on mail. Okay, it will take 2 to 3 minutes to run it. What it will do is, the last time, like those people who were present, if you remember, in case of that particular project, we were able to see. Okay. It should show us the link. It was showing us a link, right? So similarly, same thing is going to happen here also. It is going to show me a link, and then I should be able to go and copy with that particular link, and yeah, something like this. And then we will be able to see the front end. This is one way to run this particular project. I will show you some another way also, which we generally use in real time, with the help of something called as Postman. Now see, this is running on the local machine. Let me check this. Copy it, go to the browser. Let's paste it here, and hit enter. Let me check this. See here now. Now what's going to happen is, if I click on this custom file predict, what will happen is I can go and I can browse to that path where my files are. Where are my files for which I want the answer? The files for which you want the answer are in this folder, prediction underscore batch underscore files. That means these are the files which you want to give as an input, testing input to the model, which is already trained. And then it is going to create an output file. Our project is going to create an output file. It is going to put that particular file into this particular folder, prediction underscore output underscore file, and something like this will be getting it. Till now you can see the file which is created. It was created on 15th of December 2021. Okay, but today we will learn it, so that particular date you will see it is changed. Okay, everyone. So it means what? It means if I go and if I try to click on that, so I will go to the browser. This is okay, and yeah, I can go to the custom path, or maybe if I click on default file predict, what it will do is it will go and fetch the file from that particular location, and then it will give me the output, or it will show the result that the file is saved at this particular location. You can go and you can look at it. Now see everyone, I will try to do this. Let's click on this. So what it will show me is, it will show me the location where that particular file is going to be created. That is the output file, the output of the testing data. That means patients classified as affected by primary hypothyroid, secondary hypothyroid, negative or compensated hypothyroid. See how much time it will take. Yeah, I detected new results. I told you already. See, prediction file created at, so it's showing me location. Now see everyone, what is the location? The location is prediction underscore output underscore file prediction.csv. This is the location, right? So what I will do is in my current directory I will go to this particular folder and in that I will check this file. Prediction underscore output underscore file. Prediction underscore output underscore file. Inside that if I go and now I will hover my mouse here, see everyone, the file which I am able to see now, it is created on 27th of December. That is today's date. And you can check in my system as per the current time, 48 minutes past 15. Right? So see, 48 minutes past 15. That means this particular file is just now created. Okay, again, just check this. Now, if I go and if I open this file, this is the final output area. This is the final output. See. So this is a file which we are going to send it to the client as a final output. See, first patient is affected by primary hypothyroid. Second patient is affected by primary hypothyroid. This patient is negative. This patient is affected by compensated hypothyroid. Because obviously, client has not given us the name of the people. Maybe they do not want to reveal the information. They don't want to reveal all those details. That's why they might not have given all those details. So see everyone, this is what our final output. And this is the file which we are going to send it to the client. Right? This is the file which we are going to send it to the client. Output file. Right? So everyone, you can see like why all these modules. So each module has a specific purpose, and even data is also going to be validated. So in this project we have done everything like data fetching, data cleaning, pre-processing, analysis, validation, training, input output split, training testing split, machine learning algorithm, application we have done, right? Applying proper machine learning algorithm and applying more than one algorithm, and then making use of ROC ASA score, which is the best model, right? And then finally getting the model itself, and then converting it to an end-to-end application, and even the deployment part also we have done. So finally, the notes, if you go to check it out here, the deployment steps are given for pivotal cloud. Okay, pivotal or cloud foundry. One can make use of Salesforce.com or AWS or Azure also, or GCP also, Google Cloud Platform. Any one of this you can actually make use of if you are aware of it. So even all these steps are also given. So this is the execution which I have shown you, right? Now this is one way to execute it. Another way also is there to execute this particular project. That is nothing but with the help of something called as Postman. So there is, in that case, there is no need of UI. Suppose if I stop here, right? And if I go and if I refresh this, obviously I will be able to see that it is going to show me the error. So let's suppose we do not have a time to go and to test the model with user interface like this, okay, a page like this. So maybe instead of that, what one can do is one can make it of something called as Postman. Let me show you again what the Postman is. It's a API testing tool, I can say, application programming interface. So you will see, I will go and I will try to run the same project now, but through Postman. Let's see. See here, this is nothing but Postman. This is how it looks like. Now what I will do is now it's not running, right? I will once again run the project. I will run it. Because obviously before going and sending the input to the project or application, your application itself should be running, right? Otherwise how it will reply. Now see here, it is running on this particular address 127.0.0.1 folder 5000. Okay. So I will show you how to run it from, how to send the input from here. So I can use any method, get or post. I will use post method. Okay. And our model is divided into two parts. Prediction. As already I have run it, that's why I am able to see it. You will see 127.0.0.1. This is the localhost where our machine is, where our project is running, and 5000 is the port number on which it is running. Now, from where I came to know that, so if you go and if you check this in the code, like the main file everyone here, in the last problem statement also I showed you app.py, that is nothing but main.py. This is our main file everyone. You can see our model is divided into different routes or routes. One is predict route and another one is train route. Okay. And even I already told you one needs to spend some time after the session also, one needs to spend some time to understand all these things. Okay. So predict is one route and train is another route. So we are already trained the model, we are not going to train the model once again because otherwise it will take a lot of time. So I will just go and I will do the prediction. So see everyone, I want to make the prediction, and prediction we are using something like this file path. So what is this file path? This file path is acting as a key. So this is what we are going to pass through post1. See, I am here in post1 127.0.0.1:5000 and then slash I want to make the route called as predict. Okay, predict. So this is how I am going to use it. And I will go to headers. Here I will try to write down the content type. So I will be passing the input as a JSON file. So what I will do is I will use the content type here, and here my application I will show as a JSON, because I will be sending the request as a JSON file, key and value pair. Then go to this body, click on this body, click on the raw, and then in the raw, see everyone, what I am using is file path : prediction _ batch _ files. So what is file path? This key and this is the key actually. This will act as a key. So this name we are just simply using as it is in Postman. And what is the file path? We are passing the path of the input file. We are assigning the path of the input file to this particular key. So this is the key and the actual path is value. So what is this prediction _ batch _ files everyone? Prediction _ batch _ files is nothing but the file for which we want to give the answers to the client, or the file for which we want to find out the class to which a patient actually belongs. Primary hypothyroid, secondary hypothyroid, compensated hypothyroid, or maybe negative. Okay, this is what we want to find. So it is also going to give us the same answer, but this is the another way to run it. So now if I go, if everything is right, if I go, if I click on send, I should send the request to the application, and our application should reply the result. Like obviously what it will reply, it will show us that the prediction file is created at the location named as prediction _ output _ file. Right, this one. This is the location where prediction file is actually created. Okay, and then it will show us the actual prediction file. So what we'll do is we'll come here, and here you will be able to see in today's date it will be created according to current time. So obviously now it's today's date, but the time will change in our case. So 48 minutes past 15 it was. It will be something different according to the system. Whatever the time you right now are able to see, the time at which I will be running it, same time we will be able to see when I hover my mouse here. So if I go and if I try to send this, if I click on the send button, the request will go to the application, because see everyone, this is called an API, application programming interface. We are simply going and testing that API. So in many data science and machine learning teams, you will see that there are people who are working as API testers. So or otherwise developers also do this. They go and they try to test the API. So to test the API, we have a tool called as Postman. And again, there is not only Postman, there are other tools also. But Postman is somewhat generally broadly, most of the time it is used, widely used, and that's why we are also using the same thing. So if I go and if I click on this, now see everyone, as compared to earlier, it has given me the result very fast. Because Postman is again a lightweight, it will not require much space. As Postman doesn't require that much of space, so what happens in case of Postman is, it will show you results faster. It will show you the results faster. Right? It will process the request faster. And that is the thing. See, we got the result. So it is showing us prediction file created at prediction _ output _ file prediction.csv. You can check the current time, 58 minutes past 15. Maybe if I go to that particular file, prediction underscore output underscore file, we'll be able to see this file, but with current time. See, 57 minutes past 15. Just check it, just 1 minute before. And if I go and if I check out this, obviously exactly the same file I will be getting because the data set is same, right? So same output I will be getting. You can see this is the final. Okay, so this is our final output. This is what we try to achieve. And for doing this, we have done a lot of things: data fetching, data cleaning, data pre-processing, outlier handling, right? Then standardization, normalization, and we also taken care for input and output splitting, and we also taken care for train test splitting, and then applying the proper algorithms. Before that, clustering, and then applying the algorithms, and then getting the models as per the clusters. Right? And finally, the deployment part also. All these things will taken care of, right, to get this kind of output. So I will close this for now, and hope I think at least the basic idea you got about the project. That what is the project all about, what it is really doing. I hope you got that basic idea, right? So you can check this element as I can show you. As I showed you the output itself, right? As I showed you the output itself, everyone is able to see the final output, and that final output we are saving it in a file. But is it compulsory to save the output in the file? No, it totally depends on. It totally depends on what type of output, like what type of format the client wants to save the output. It totally depends on that particular thing. Otherwise, it is not compulsory. Even one could have saved it to some another place also. That's also possible. That's for sure possible. It's not like that one should be sending the output only to the CSV file like that. Whatever the location client is going to ask you to put that particular file, we should be able to send or put that particular file to that particular location. So I hope you are getting the point, but still anyone like those who are listening me by chance, so if you have any question, you can always let me know in the chat box. Fine. I hope there is no question. So maybe I can go and I can talk about the steps, general steps. See everyone, whenever we talk about any project, there are some general steps which we apply. Not only for this particular project actually, but for any other project, any other project. So thyroid detection. I will give the name as thyroid detection. So everyone, as I told you, there are general steps. I am not saying that exactly the same steps you will see everywhere, but more or less you will be able to see that something similar is also applied. Right? Something similar I am going to say, maybe some less number of steps, but in real time you will see exactly same thing happens. Okay. So problem statement I have already shown it to you. To build a classification methodology to predict the type of thyroid based on the given training data. This is what our problem statement is. Now what we want to do is, the first thing, always, like whatever may be the project, it's not like about thyroid detection or thyroid classification only. Whatever may be the project, the first step is always going to be data ingestion mechanism. Okay. Or even maybe, I will go with the first step, even before that, what happens is, see, there will be meetings between the client and your organization or the company. Now the people like leads, okay, the people like project architects, okay, or maybe even the managers. As I told you everyone, I am talking about general steps in any project, machine learning example. Okay. So leads, project architects, managers, maybe sometimes team leads and so on, senior people, right? So these are the people who are who will be involved in the initial discussion. They will discuss with the client. Okay, leads, project architects, mainly managers. These are the people who are going to discuss, or maybe the higher authority people, right? So all the higher authority people, they will be involved in the initial communication with the client. Okay, so they will try to understand the requirement of the client. So they will discuss with client. These are the people who are going to discuss with the client. And obviously, there is not only one meeting which will be held, there will be multiple meetings which will be held. In the first meeting, client will say something, client will try to put the requirement, right? And maybe the organization or the company people, they will try to understand the requirement, exact requirement, what client actually wants. And then maybe after that, several other meetings are going to be held. One after the other, several other meetings will be held. And there will be different questionnaires. Client will try to tell whatever they want exactly, and the people who are going to develop it, they will try to understand the things, and they will try to suggest something. Then client will make changes, or client will suggest something. So like this, multiple meetings are going to be held, and then finally they will come to the conclusion. And some remaining things also they will be discussing, like how to validate the data, what type of data is coming, how many number of columns are going to be there, how many files are going to be there, how data is coming, what is the location, do we have the access or not, how many people can access it, and so on. Okay? And so on. So number of things will be discussed. And then once the discussion is done, then if the client has given the access, okay, so we can say that this data ingestion mechanism, this will be decided. Data ingestion mechanism. Now, data ingestion mechanism is what? See, it means reading the data, reading and getting the data. Read and get data from client. Okay? That is nothing but data ingestion mechanism. So data might be coming in batches, even that is possible. In our case, data is actually coming in batches. But data is not only in batches, data might be coming via streaming also, like online streaming. That's also possible. Data might be coming via streaming, or maybe some there might be use of some messaging techniques. If you are not aware about different messaging techniques, don't worry. These are some sources, I can say, sources of the data. Data might be coming from messaging, like there's something called as Kafka. Okay, Kafka messaging is there. Then there's something called as JMS messaging is there. So different messaging techniques are there through which data can be coming. Or data might be coming through FTP, file transfer protocol. It might be coming through other things like through some REST API application programming interfaces. That's also possible. Client will give a link and they will ask you to fetch the data. Or even data might be coming from some databases. Now, whenever I say database or databases, there are different databases, right? MySQL is there, Oracle is there, there might be DB2, there might be MongoDB, and so on. Again, even the databases, a lot of them they are there. Cassandra can be there, right? HBase can be there, and so on. There are a lot of databases through which data might be coming. Okay, and then their data might be coming through data warehouse also. That's also possible. Data might be coming through data warehouse, right? Even data might be coming through some ETL pipeline. That's also possible. I'm just trying to put all the resources of data or sources of the data. And again, it's not compulsory that data is coming only through these sources. There are different sources possible. I'm just trying to give you an overview. Okay. So see, After like leads, project architects, if once they decide, then there will be decision on data ingestion mechanism. Okay, data ingestion is nothing but how the data is going to be read and saved or fetched. Okay, and then the third thing is once the data is there, right? The programmers or the people who are going to work on the particular data, they will try to understand the data by describing it. Now, everyone, if you remember, like the packages which you have understood, there are different packages which we have used. Like specifically, we have used NumPy, or you must have seen Panda. So, with the help of those packages, it will be tried to describe the data to understand something about data, like how many number of records are there in data, what is the average or mean value of every column, what is the mean, mode, median, what is standard deviation, and so on. So there is a direct method in case of pandas package. If you do it like data frame name, okay, data frame name is let's say df. So if you do data frame name dot describe, you will be able to see all the details like what is the count of the records in each of the column, then what is the average value or mean value, or what is the 25 percentile, 50 percentile, 75 percentile, or we call it as quartile 1, quartile 2, quartile 3, standard deviation, what is standard deviation of that particular column. All that information will be getting in it. So which will help us to derive some other things, right? That particular data is again very, that describe output is also again very important, because it will help us to know a lot of things. It will help us to know a lot of things. This is one thing. So here also we will be able to see that we will be making use of pandas package, numpy package, matplotlib, cbon, and so on. Right? I hope you might have used it. Then generally, like maybe this step can be earlier also. There will be a contract between both the parties, right? There will be a contract between the client and the people who are going to work on that particular project. So what happens generally in the contract? Why am I talking about it here? Actually? So let's suppose they will decide that okay, whatever the data which client has sent us for training, now same type of data they should send us in testing also. Because obviously if you train the model on 30 columns and they are giving you 40 columns of the testing data, it is not making sense, right? It's like you train the model to identify a car in the image, and they are giving you the images where there are, like, let's say, cat and dogs. Obviously, that's not good, right? Every time it will not detect anything. Or I mean to say, on the data, whatever it is trained, the format of the data for testing also should be same. So I mean to say, data columns will be same. Just one example of the contract, data columns will be same. And here I will show you. In our case, also client has given us one file. Here, client has actually given us one file. Let's stop this. Okay. Client has given us one file actually where they have already mentioned these things. See, I will show it to you again. Client has given us this file, JSON file, schema underscore training.json and schema underscore prediction.json. If I click on double click on schema underscore training.json, we will be able to see a JSON file here. JSON file is key value here. See, they have given the name as sample file name, hypothyroid underscore some digits underscore some digits.csv. So you can see that it means a file name should start with hypothyroid, and then there should be underscore, and then there should be some digits, and then underscore, and then again digits, and then .csv. This is what they are expecting a file name should be. And then they are saying that this is actually date stamp and this is the time stamp. So you can see 0801 to 2020. So they are saying that length of the date stamp in the file can be at least max 7, length of time stamp in the file can be 13, and number of columns should be 30, including the output column because it's training data. And the column name should be like this, age, sex, on-tariff, and so on. And their data type should be as this. So client has already given this particular information for training files. In training files, there should be an output column, and that's how this class column is there. Now, so this is according to the contract between both the parties. Okay, according to the contract, whatever they discuss in the meeting, right, according to the reduced time. And same thing they have given us for schema underscore prediction dot decimal set. See, the only thing is obviously here you can see that there are 29 columns because obviously it's a prediction file. So output column is not given, class column is not given. That is what we want to come up with for this particular testing data. Okay. So the thing is, whatever I am talking about, the steps which I have mentioned here, data columns will be same. So that is one validation criteria, or in short I can say that in the contract they will decide about data validation rules. So whatever the data which is coming from the client for training or testing, is that data really validated, right, or how it can be validated, that will be decided depending on data validation rules. This is the fourth steps, fourth step I can say. Then the fifth one is internal processes. Okay, internal process. Now, what do you mean by this? It means you need to define your own schema. Here, you need to define your own schema. Now, everyone, what is the schema? Schema is nothing but the design, the structure. Whenever I say schema, there are two types of schema, rather three types of schema actually. The first one is star schema. Then the second one is snowflake schema. Schema is nothing but whatever, it's a design. Maybe those people work from databases, they must be knowing it. And there is one more actually, I think something called as, I don't remember the name, quantification schema, something like that. Okay. But again, generally use this one, snowflake schema. So if I want to give the idea here, everyone, if I want to give basic idea about types of schema, so it's nothing but just a design, how you are going to store the data. Okay. So in the databases, that will be decided. Let's suppose this is the main table, okay, which we call it as fact table in your database. So to this particular table, this table will be, let's suppose it is joined. To this table, this is another table which is joined, and this is another table which is joined. This is another table which is joined. Okay, everyone. So something like this we have. Something like this we have. So if the tables are joined in this fashion, this is called as star schema because the design is like star. Star schema. But so you can see all these tables are joined to this middle table, fact table. Okay, so they are joined up to only one level. Okay, this is called a star. But to this table in turn, so this table joined to this, and to this table in turn, this table is joined. So this is nothing but now snowflake schema. So again, how the data is going to be like stored, that is also decided in the meetings. Okay. Defining the own schema, defining your own schema, or I can say that defining your own database schema. Okay. Like define internal storage strategies. This will be done. Define internal storage strategies. Okay, and maybe aggregation strategies because you are going to combine the data or not. Okay, that also will be decided. Defining internal storage strategies and aggregation strategies. This will be decided to combine every data or not. So what we will be doing actually, like those people who are present from the start, if you are listening me. Now in our case, the data which client has given us, right, like let's say training data, right, training batch files. So the training batch files are like all these files, right? So are you going to combine this data at one place? Maybe yes. So you have to use some database, right? So all those things will be decided into internal process or internal storage strategies. And then once this is done, in the real-time project, what we do is, like once it is decided how to save the data, we go with the pre-processing on the data. Now pre-processing itself takes a lot of time. Pre-processing on data. That's why generally people think that okay, when we talk about machine learning and data science, it's all about coding. No, it's not like that. A lot of time is you need to give it for handling the data itself. So pre-processing on data, it means what variable? Pre-processing is nothing but working on the data, try to handle the missing values, try to handle the outlier values, try to standardize the data, try to normalize the data, and try to see if there are some unwanted columns, try to do some transformations on the data if needed, and lot of things are there. Okay, there are different techniques which you generally make use of to make our data suitable for training, and to make our data to pass it as an input to the algorithm. Okay, whatever the algorithm which you are making use of, we should be able to pass that particular data as an input to the algorithm. Right. So pre-processing on the data itself is a lot of time it takes depending on the size of the data. Fine. So once the pre-processing step it is done, now everyone I told you at the start itself, right? Clustering approach, right? So one can go and one can perform clustering on the data. One can go and one can perform clustering over data. And I told you everyone, right? Clustering is nothing but what? Grouping. Clustering is nothing but what? Grouping. So how to do that? K means DB scan. I already told you, right? K means or DB scan one can always make use of. Right? This is DB scan. I have already shared the link in the chat box area. Right? If you want to learn about it. Or even K means is also there, so you can use any one out of that, depending on the data, depending on your knowledge about that particular algorithm, and depending on your knowledge about the domain or that particular data from which you want to train the model. And once the clustering is actually performed, and then finally the model selection and model tuning is going to come into picture. So how to train the model, we already seen in some linear regression, something similar. Model selection and model training. This will definitely come into picture. Model selection, model training will come into picture, right? We can see that these are all the steps which we are going to apply in real time. That's why I say that I will be showing it to you in reverse way. First of all, I show you the execution, everyone, by using UI, user interface, as well as I show you something called as REST API method also, right? By using something called as Postman. This particular thing also we have used Postman, and we got the result here. We got the result. So these are some of the steps, and yes, not only these steps, everyone, there are some other remaining steps also which I will be talking about. Okay, so as we have seen model selection, so after model selection, you will be able to see that. So 9 step, let's say I want to show you here. Once the model selection is done, and then finally what? Save the model for each cluster. Saving model for each cluster. As I told you, right, we never depend on only one algorithm. We go with at least 5 to 6 algorithms, depending on the clusters. If we have 5 clusters, we'll go with the 5 algorithms. Let's say. Not like that. On every cluster, we'll go with 4 to 5 algorithms, and then we'll be choosing the best one out of that. And how to choose the best one, I already told you. ROC, AUC score is the thing which we can actually make use of, right, to go and to come up with the best model. And finally, the 10th step I can say, the model whatever we have staked. So save the model for each cluster which we have got in the training data. Right? This will be for training data obviously. Because training, from training data only we will be getting the models. And then for testing we will just go and do the prediction or classification model. And then the next step is going to be use saved model for prediction or classification. Use saved model for prediction or classification. Use the saved model for prediction or classification. Depending on whatever the problem statement you want to solve, you can go and you can use the saved model for that particular purpose, right? And then once the model is saved, once the model is saved, everyone, what you can do is just write down here. Okay. So once you save the model, one can go and one can save the prediction of the model, save the prediction of the model somewhere. Okay. Save the prediction of the model somewhere. As like we are saving the prediction of the model of our project in this particular directory. Let me show it to you properly. In the file, in the folder called as prediction underscore output underscore file. Okay. Yeah, here. You see, we are storing our prediction here, right, in this file. This is the output. This is our final output which we are going to send it to the client. Or maybe we will put it at some location where client wants us to put that particular thing. Right? At that location, we will be putting this particular file. At that particular location, we will be putting it. So this is what everyone you can see. This is the final output. So that's what I am saying. That's what I am trying to say. So hope like those people who are listening me from the start itself, at least they got some basic idea here. Okay. Definitely, I am not expecting that you should understand the complete project and the code. No worries, but at least the flow. That's what is very, very important. So see, save the model prediction somewhere, maybe on server. You save it so that client can go and client can actually check it out and make use of that particular prediction. Okay. And finally, everyone, what? Finally, obviously, currently the model is running on local machine. But obviously, is it going to help the client if the model is running only on one machine? No. The people who are going to make use of that particular model, the end users who are going to make use of that particular model, end users may be using it from anywhere at any time, from any location, right? So obviously, deployment will also come into picture at the end. Deployment to some what we can say, to some of the cloud environment. Okay. Deployment to some of the cloud environment. And generally, like the model which I showed you earlier, everyone, it was deployed onto Heroku Cloud. It was deployed onto Heroku Cloud. Okay. And generally, whenever I talk about the assignments and all those things, generally we try to deploy it onto AWS Cloud. I show it with AWS or Heroku Cloud. It is now called as Salesforce.com. Then there is something called as Google Cloud Platform, GCP. Then there is something called as Azure, Microsoft Azure, and there is one more that is nothing but Feudal Cloud. So all the steps for Feudal Cloud are actually shown in this particular documentation. In this documentation, all the steps are actually shown. So this is the last step. Deployment is always going to be the last step. So I hope at least you got the basic idea about all the points or the flow of project, whatever we apply in real time, starting from data fetching. So see what I have shown to you, everyone. You can see that. You can actually see that this is the first step, right? There will be a meeting between the higher authorities and the client, and then there will be decision about data ingestion mechanism, right? So data ingestion, I told you, data might be coming into from batches, like in our case, it might be coming via streaming or some messaging techniques like Kafka and JMS, maybe FTP, file transfer protocol, REST APIs like these databases, and even I did not mention, but data might be coming, or if it's a big data, it might be coming from Hadoop, right? Maybe Hive is used sometimes, and lot of different databases are possible, like Cassandra. This also can be possible, and so on. Like you might be knowing that there are a lot of sources which can be possible. It can be a sensor data. A lot of them they are possible, right? So data ingestion mechanism: read and get data from the client. Client will tell you how to get data. Client will tell you how to connect, and everything they will help you. And then the we go and we try to understand the data with the help of, let's say, Python by describing the particular data, right? And then again there will be a contract between the parties, right? Like let's say the columns, data column should be same, right? There will be some data validation rules which about which they are going to decide, right? So how the data validation rules are going to be. I have already shown you JSON file in my case, right? Those JSON files are given by the client. It means client are saying, if client is saying that the file name should start with hypothyroid or something else, so that should be followed. If the file is not, if a particular input file is not following all those rules, then obviously that is wrong, and we need to go and we need to resend that particular file to the client, and client will go and correct it. That's how it is going to be done. Okay, and finally there will be some internal processes that will also be decided, right? So we need to go and this will be decided, defining database schemas, defining internal storage strategies, how data is going to be stored, whether it will be stored in tabular form, rows and columns, or key-value pair, or what. There are different ways to store the data. So these things are also be decided. Internal storage strategies, and then pre-processing on the data. This also I have given the idea, and even I have shown you with the hands-on example also. Even in linear regression algorithm itself, we have seen that, right? Data cleaning, pre-processing. So missing values, how to check it out, outliers, how to check it out, how to handle the missing values. We already seen case of linear as well as in logistic regression also we have seen most of the part of it. That's also one thing, right? So pre-processing on data that will be applied, and then perform the clustering over the data. Perform the clustering over the data. So this particular part at the start itself I told you, right? This is one of the best approaches uh, to start with, and many times many people make use of this. Across the industry, everyone will see that people make use of this particular approach, right? So you will see that again, not only this, even there are other approaches also everyone, but this is one of the best approach which many people prefer making use of. That's why I'm just trying to put this particular thing in front of you, right? So hope this particular thing also you are able to make some sense again. But as I told you, not only this approach, but you see that there are other approaches also. But overall, most of the times you will see this approach is applied, clustering. Okay, if you apply it, always good. There is a chance that like your model will be having very good accuracy. Okay, because going and it will take less time. That is the main point why we apply that kind of approach. If you do clustering first and then apply the prediction or classification algorithm, the speed with which the model is going to give the result or it is going to access it, that is going to be faster than everything. Because why to go and why to read the unwanted rows or unwanted records, right? Instead of that, we just try to read whatever is required and then go and then try to fill the result. That's what we also try to do here. Okay, hope you people are getting the reason behind this. Why we go and why we try to apply something called as clustering. And I told you that k-means is what we can make use of in case of clustering, but it is not only k-means. It is not only k-means. Instead of k-means, one can go with dbscan also. That is also really very good algorithm to go with. And specifically for big data, it is really good. Density based spatial clustering applications with noise. That is the dbscan algorithm, which comes under unsupervised learning approach, as I told you earlier, which can be used for clustering types of problems. So for doing clustering only, we make use of either k-means or we make use of dbscan. Many times people go with this. Maybe there are different reasons. Maybe they might be aware about only k-means, or maybe they might be knowing that k-means gives very good results. But do not ignore dbscan also everyone. You should be knowing about it. Okay. So I already shared the link. If you are maybe those who are already working in something like this, you can always go and you can always check it out. Okay. So perform clustering over the data, and then finally model selection area. So I told you something called as ROC AUC score. Receiver operator characteristics area under the curve. In logistic regression, I told you and shown you the execution of this already. Right? Those were present. Hope they remember it. Model selection and model training, and finally save the model. And now talking about saving the model, everyone. In case of machine learning, models are stored with this extension. I should dot pickle, or even models can be stored with dot sav. In machine learning, this is how we save the model. But in case of deep learning, models are stored with dot h5 extension. Dot h5. Okay, in case of deep learning, models are stored with dot h5. In case of machine learning, models are stored with dot pickle extension. Okay, and when the model is saved, then use the saved model for classification or prediction. Whatever you want to do accordingly, you go and you try to use the model for that. Right? Either classification or prediction. So one can always go and one can make use of that particular model according to the requirement. And finally, once it is done, save the results, save the prediction somewhere, classification results or prediction results, whatever you have, save those results somewhere. That is it. And once the results are saved, maybe client can refer to the results. And obviously, deployment. Deployment on some of the cloud platforms like Amazon Web Services, Heroku or Salesforce.com, Google Cloud Platform, right? GCP, Microsoft Azure, and Cloud Foundry, few of them are. Or any other clouds like Alibaba Cloud, and number of them they are actually available. But these are some of the famous cloud platforms which are available and which is generally used, make use of. Okay. Out of this Heroku is free for 2 years. You might be doing about it. You don't have to enter any credit card details or debit card details. But for all the other clouds, you will have to enter credit card and debit card details. All the other clouds are free for 1 year. Heroku is free for 2 years. It provides you 500 MB of space and no need to enter the credit card details or debit card details for Heroku. That's why generally I go with this. Like whenever I want to explain things. Okay, everyone. So these are all the steps given for the project which I have shown you just now. Now let me know if you have any question, anything to add here, any doubt, you can always ask. Right? These are all the modules. I told you I am not expecting that you should understand the code, but at least the flow. At least the flow, what happens in case of machine learning and data science project, at least that particular thing, the idea behind that, how we go, what is the approach, what are the steps which are which generally come into picture whenever we talk about machine learning and data science project, where the analysis actually comes into picture, where development comes into picture, where testing comes into picture, where deployment comes into picture. That is the thing which I want you to make aware about. Because see, one can make use of any language. It's not like about it's not like you can use only Python and you might be doing right. Even one can make use of even C, also Java also. Now there is different languages which are available everywhere. Ruby is also available. R is there. Python obviously is going to be there. Python is obviously it's easy. It can be used for any domain. You just talk about the domain. Python is there, and it's easy to understand. That's why usually people go with this particular. But whether you talk about classification or maybe you talk about prediction, you will see that even you will see that the flow is more or less same. The flow is more or less same. Okay? And all these are nothing but what? All these are nothing but the different modules in my project. These are all the modules. If you really see, the starting point of this particular project is this main.py file. This main.py file is the starting point. So if I try to show you, see here I am importing everything. You can see everyone. I am importing something called as Flask because I just wanted to show you UI, some HTML pages I wanted to show you, right? So yes, I am simply going and importing all the necessary libraries. So this is whatever you people are going to see this particular code actually. This is a simple Python code. If you people are aware about Python and some basic packages like pandas, numpy, matplotlib and cbon, yes, you will be able to understand this particular code. As I told you, all these are nothing but different modules in the project. Okay. So the starting point of this is going to be this line. In main file, the compiler is going to start with this particular line. Obviously, it is going to read the code line by line, but either when it comes to this particular it always looks out for this particular line. That is nothing but if underscore name underscore equal to underscore main underscore. This is the line which it looks out for. And then here you can check that it is able to see something called as app.run. So as soon as it sees app, so it will go and it will check out what is app. So as it has already read the thing, so it will come to know that okay, app is nothing but object. App is nothing but an object is created, and that object is of the type Flask. That object is of the type Flask. And how am I able to use this particular Flask? Flask is actually a framework area. Flask is actually a framework, and I am able to use the Flask because I already imported this particular. Okay, from Flask I am importing Flask. That's why. So if you want to install anything, everyone you might be doing that. How to install anything? So here is a terminal. You can run this command. Pip install and the name of the package, whatever you want to install. And even if you are not able to remember this everyone, or maybe for any other package, if you are not able to remember the exact command, right? See, all the packages in this particular project, whatever you require, when you will get it, you will get a requirement.txt file. Generally, what we do is at the end of the project, once we install all the packages individually one by one, what we do is, as let's suppose I want to run this particular project on some other machine, so I will not go and I will not install all the packages individually. Instead of that, what I can do is I can go and I can create a file called as requirement.txt, and then in that particular file, we generally put all those packages. So this requirement.txt file, how I created everyone, once the installation is done, all the packages I install on my machine, the project are running fine. After that, I created this particular file. How I created it? So with the help of this particular command, pip install greater than sign and then requirements.txt. Requirements.txt. This is what I created. So this particular sign is called as output redirector. This is called as output redirector. So whatever the things which we installed on this particular project, all those things are going to be written in this particular file like this. So whatever you people are able to see everyone, what are these? This is nothing but the package name and the respective version. Package name and respective version, you people are able to see here. See the package name and the version. This is what you people are able to see. So you don't have to install all these packages individually. What one can do is, as everything is in this particular file, so I can run this command, pip install. I can do it like this, pip install and then requirement.txt. If I enter, it is going to install all the packages onto the machine, and then maybe one can go and one can try to run the project. If it shows you error, then you go with the individual installation of the package. Otherwise, all the packages which we used here, or like for this project, whatever I used, all the packages are here. All those packages are written here. Obviously, one needs to take care about that, right? Otherwise, how will you run the project? It will not be possible, right? It will not be possible to run that particular project if you don't have the packages. That's why going and installing the packages is very, very important. So you can see that this is the main file, right? So this is the starting point in the main file. It always going to look out for this particular line, right? As and when it sees this particular line, I can see app. And now, as and when it is on app, it will understand that okay, app is nothing but the object of the type Flask. I am able to use Flask because I already imported it here. Okay, and then with the help of the Flask, we divided this particular project into different routes like this. app.root slash is the first route, then predict is the second route, and there is one more route everyone, that is nothing but train. So whether you want to train or predict, accordingly we can go and we can actually use the route. This is how it's going to work. So as you can see that in slash root, what I am doing is I am using @cross_origin. Now what is this everyone? It means that like when I will deploy this particular project onto cloud, now what I want is I want everyone to make use of this particular application. Not only me or not only from my machine, but a person if person is in another network. See something like this. What I mean to say is now my main.py is running on some location on server in some network, it belongs to some network. This is where my application is actually running. Now what we want is a person who is not in this network, he should also be able to make use of this particular application. A person who is not in this network, right, they should be able to make use of this particular application. So that will be taken care by something called as cross underscore origin. So this will take care for cross platform. That means even if the person is in some other network, he or she will be able to make use of my application from anywhere at any time from any location. And that is possible because of cross underscore origin. And I am able to make use of cross underscore origin because we have used class underscore course import course and cross underscore origin. This will take care for cross platform. Okay. And now we can see that like it is rendering index.html. What is index.html, everyone? Index.html is a HTML file, whatever the front end which we are able to see, right? Whatever the front end which we are able to see here, everyone. So let me go and let me try to show you. See this one. So this front end we are able to see because we have written this particular code in the HTML. If I go here, if I inspect, we will be able to see the code everywhere. Now, do you really need to worry about this? No, actually, it's not difficult. One can go and one can write on this particular code, right? Or even maybe you can take it from anywhere if you want. Just simple HTML code, everyone. You don't have to worry about this. And again, that is not our task to write down the HTML code. Okay? There will be a separate person who will take care for writing down the HTML code. But as an example, as we wanted to show it to you, that's why like I am showing it to you that this is the front end. Okay? Otherwise, again, there are a lot of ways to develop the front end, but let me tell you that is not a task of a data scientist, machine learning engineer, data analysis, or Python developer's task. It's not our task to go and develop this kind of a thing. There will be a separate person who will actually do that. Okay. Fine. Now see, everyone, as I am telling you that we have this particular thing, right? We have the final output here, right? So this is one example I am showing you. It's not necessary that one should be storing the output in the CSV file. That is also one thing. Okay, that's also one thing. It's not at all necessary. The output can be in this format, or maybe the output can be in some other format also. That's possible. It totally depends on the client, in what format the client actually wants. But generally we use CSV file, Excel file also, because accessing the data from the file is faster as compared to accessing the data from the database. And now see everyone, first of all this file will be showed, and then our model is divided into different rules. So predict rules. So if you want to do the prediction, whenever when I showed you, when we clicked on that particular button, right, like this button, and when I clicked on it, I got this one. How I got it? Because this particular route has run. And here we are taking care to pass data as an input, training data, and then we are passing the path of the data file. Our files are here for which we want the answer, prediction underscore byte underscore files, and the final output is actually saved here. See, this is our final output, which I already showed it to you by going to that particular location. I already showed you. And see, index.html is always a templates folder. Template is a standard folder. You might be knowing about it. It's a standard folder. If you are aware of basics of Python, you might be knowing that templates is the standard folder whenever you want to go and you want to create the front end. Right? This is how it is going to be. Okay? And this is my main file. So if you like, maybe as I told you earlier also, but no one has approached me. Only 2 people has approached me for the notes actually, but those who need it, I am ready to send this one also, no problem at all. So see, what you can do is, if you really want to know and understand all these things, you should be aware about some basics of object-oriented programming, classes and objects. See, what you need to do is, if you want to understand how these methods are, just go here, click here, press Control button and hover your mouse. Click on this, and now you will be able to see something like this. That's what you need to do. Okay, press Control button, hold your mouse, click on this. That's it. This is what you will be able to do. Right? So this is all all about the project everyone, and whatever the steps which I explained in general steps, same steps are here. Start, data is coming into batches for training, you do the data validation according to the rules which client has provided us, then do the data transformation, right, adding the column, removing the column, data insertion into some database. What we generally do is, whatever is the validated data actually, we try to insert that particular data into database. And here I use SQLite database, which is a Lifeco database. Single command is there for connecting to the SQLite database. It is nothing but just you need to do pip install SQLite 3 and you can actually connect in a single line command. And then export that particular data from the database to CSV file for training. And then do the data pre-processing on that, handling missing values, outliers, standardization, normalization, everything. And then clustering also I told you as well, and then get the best model for each cluster with the help of ROC, which is score, and if needed, apply hyperparameter tuning. Hyperparameter tuning is nothing but what? It is nothing but we apply some techniques, we try to tune the parameters, we try to tune the attributes of the algorithms so that we should get the higher accuracy as per the expectation. And finally, save the model as a .pickle model or .sav model, and then if needed, go and do the cloud setup, push the application to the cloud, and the application is going to start working. So all these steps, whatever till this application start, all these done are these are actually done for what? In training phase. And in testing phase, even on prediction phase, data will come from the client, we will do the data validation, data transformation will be done, data will be inserted into database, and then from database it will be exported to a CSV file, because accessing the data from the file as compared to database is faster, and then data pre-processing will be done on testing data, and then data clustering will be done. No need of model training because model is already trained here. Okay, so we will go and we will use a specific model as per the cluster, and then final prediction will be getting for the testing data, and then the prediction actually or classification, whatever it is, we are going to save it in the CSV file, and that's what the complete flow of the architecture of the project is. And all the other things about data set, actually whatever I explained, all those things are given in the documentation. See, obviously we have used Jupyter notebook also, and once everything is finalized, we have gone with the PyCharm, because PyCharm is something which is going to help you to create the end-to-end project, and everything with a screenshot is again shown in the documentation with the explanation. As I told you, those people are interested, definitely they can go through this and they can check this out. Even cloud steps are also given for deploying this particular whole project onto cloud. One of the applications we already deployed, and I already seen to the link for deployment. Right? I hope at least this will give a basic idea. And how to run your project in something called as Postman, I already showed it. Okay, everyone. So let me know now. Like by chance, if someone is listening me, let me know any doubts. If you have any questions, anything, any suggestion, please let me know. Okay, well, then I will share the attendance link with you. Just a minute. Let me share it.
Hello, sir. Hello, sir.
Thank you, Abhijit sir. Thank you. So, hope this will help everything. Just give me a minute, everyone. I will be going and I will be sharing my attendance. Yeah, thank you, Gita madam. Thank you, Arthur madam. So I think Vishal sir is sending feedback link. I'm going to send you attendance link which he has sent it to me. Just give me a minute. I will send it. Yes, yes, madam. I conduct the training for machine learning, data science, data analysis also. Thank you, Deepak. Thank you so much. Thank you. So actually, it's a startup named as Bharat of Solutions, under which we work in development as well as training. Yes, Geeta madam, I am sharing the link only. Yeah, I am sharing the link. Yes, yes, Bharati madam, you can definitely contact. I will be sharing my email ID as well as any WhatsApp number you already have, right? I am already in the group, that group. You can always contact, no problem. Even if you have any doubt, like any kind of, let's say even you go with project development also. Right? Yeah, sir, I will be sharing it with Vishal sir. He will be sharing the links with you. As I told you, I will be sharing the notes, whatever I discussed in these sessions, I will be doing and sending it to you. So you will be getting it to Mr. Vishal Borade sir, he will be sharing. Anyway, everyone, I think maybe later on we will refer the notes at that time also. If you face any difficulty, you can let me know. Right? So you can send it to me here if you have any query. You wish in 555 @gmail.com. And the WhatsApp number is already there in the group, right? 965 70 80 95. If you have any difficulty, if you stuck somewhere, you can always let me know.
Hello, am I audible, Yogesh sir?
Yes, yes, Vishal sir, you are audible.
So, any questions from participants for Yogesh sir?
I think they are asking about some notes, some of them they are asking. Vishal sir, I will be sending it to you. You can always you can forward it to them.
Okay, fine, sir, fine.
Yeah. And just a minute, I will share the attendance link.
This link is about the attendance of day 5, that is about today, and I will share the link of feedback. After the filling of feedback form, you will get your certificate of FDP. Okay, so here I just want to say thanks, big thank you for Yogesh Murumkar sir for uh, giving their valuable time to our respected participant who are joining from various organizations all over India. Thank you, Yogesh sir, one more time. And
Thank you.
participants, I will share all the recordings in the in the WhatsApp group for your reference. Okay. I
Dr.
request.
Madhuri madam, I shared the number here, okay? I think you are asking me for that. I shared my email ID also and WhatsApp number is already there in the group. I am already there in that group. This is where you can contact if you are stuck somewhere.
So I
Thank you,
request
sir. Thank you.
all the participants to fill the attendance as well as feedback form for the FDP. Okay. I will share the link of feedback form